Hi Grade 12s, I'm John McBride.
And I'm Joyce Poko.
Today we carry out two different tasks with electric circuits. Firstly, we determine the EMF and internal resistance of a battery. And secondly, we compare the measured resistances of two series and parallel resistors with their calculated values.
Here's the apparatus that we will use for these investigations. We have three 10-ohm resistors, two 1.5 torch cells, a voltmeter, and an ammeter, as well as connecting leads.
The battery will be constructed from two 1.5 volt cells connected in series. Our task is to determine the EMF of the battery and its internal resistance.
We won't find the EMF of each cell or each cell's internal resistance. We are measuring these quantities for the battery or two cells in series. Three resistors can be combined in a few different arrangements so that the effective resistance ranges from a minimum of 3.3 ohms to a maximum of 30 ohms.
Before we start taking measurements for this investigation, read and complete questions 1.1 and 1.2. Press the pause button now. We are ready to carry out the investigation. There are quite a few arrangements of these three resistors. Your answers may differ slightly to the arrangements that we will use for the investigation, but never mind, they are probably correct. Your teacher will assess them later during marking.
We will use the following values of effective resistance: 3.33 ohms, 10 ohms, 15 ohms, 20 ohms, and 30 ohms. Write these values into the table of results on page 2 of your worksheet. We are ready to set up the first circuit. I'm not going to give you the answers to questions 1.1 and 1.2, so you won't be seeing the combinations of the resistors for each set of readings. I will tell you the effective resistance of these combinations each time because you may like to use them on calculations later on.
The two 1.5 volt cells are connected in series to form a battery. We connect a voltmeter across the terminals of the battery. When the voltmeter is in this position, it also is connected across the terminals of the external circuit as well. The ammeter is connected in series with the battery and the external circuit. This is going to be our switch. The combination of the resistors is connected to the ammeter and the other terminal of the battery. Have a look at the diagram of the circuit that we are using.
I've shown the combination of resistors as a variable resistor. It is the resistor with an arrow drawn through it. We are ready to take readings of the terminal voltage across the external circuit and the current passing through the battery. The first combination of resistors has an effective resistance of 3.33 ohms. We close the switch and take the readings.
The voltmeter reads 2.6 volts and the ammeter reads 0.766 amperes.
Now we will change the arrangements of the resistors so that the effective resistance is 10 ohms. The second combination of resistors has an effective resistance of 10 ohms. We close the switch and take the readings.
The voltmeter reading is now 2.81 volts and the ammeter reading is 0.282 amps.
This is looking good. Let's change the combination once more. We will work with a combination with an effective resistance of 15 ohms. The third combination of resistance has an effective resistance of 15 ohms. We close the switch.
Now the voltmeter reading now reads 2.85 volts and the ammeter reading reads 0.191 amps.
Right, the fourth combination has a combined resistance of 20 ohms. We close the switch and take the readings.
Here, the voltmeter reading is 2.87 volts and the ammeter reading is 0.145 amps.
The last combination has a maximum resistance of 30 ohms. We close the switch and take the readings.
The voltmeter reading is 2.89 volts and the ammeter reading is 0.096 amps.
Right, now you have the data. It's time for you to analyze these results by plotting the graph and answering the remaining questions of part 1 on your worksheet. Press the pause button until you are ready to start part 2 of this investigation. Welcome back to part 2 of this investigation. Our task is to measure the effective resistance of a series parallel network of resistors and to compare its measured value to its theoretical value.
Basically, we will measure the terminal voltage across the combination and the current passing into the combination. Then we will calculate the measured resistance using the formula R is equal to V divided by I. We will also use the formula R series is equal to R1 plus R2 plus R3 plus however many resistors to calculate the combined resistance of the series part of the circuit. And the formula 1 over R parallel is equal to 1 over R1 plus 1 over R2 plus however many other resistors we've got to calculate the combined resistance of the parallel part.
The point of these calculations is to show that the formulae for series and parallel resistors give us the same results as the measured value using voltage divided by current.
So before we begin, you need to draw the two possible combinations of 3 resistors connected in series parallel networks.
A series parallel network has some part of the network as a series combination and another part of the network as a parallel combination.
Take a short while to draw these two possible series parallel combinations for 3 resistors. Also complete question 2, which asks you to draw the circuit diagram for combination A, the combination with the lower effective resistance. Press the pause button until you are ready to continue. Okay, there are quite a few things for you to complete in this practical. We have also asked you to draw up a table of results. However, if you take down the results as you go along and then arrange them into a table, it will make your task a little easier. You will know how many columns and rows you will need, and you will be able to plan more effectively.
We will start with combination A. And each time we will take 3 sets of readings of voltage and current. We are doing this to improve the reliability of the data. We will take an average of the resistance for this combination from these 3 sets of reading. Right, we close the switch, turn on the meters and check the readings of the meters.
The voltmeter reading reads 2.74 volts. And the ammeter reading reads 0.412 amperes. And we open the switch. We'll wait a moment to let the combination of the resistors cool down to room temperature again. If the resistors heat up, its resistance increases slightly. We need to control the temperature, keeping it at room temperature all the time.
Right, that's long enough. Let's repeat the readings. Close the switch.
The voltmeter reading now reads 2.74 volts, and the ammeter readings is 0.411 amps. And open the switch.
Remember that we will use this set of data to calculate the measured resistance of the combination A using the formula R equals V divided by I. You will need to include a column for those calculations in your table of results. So now, let's take the third set of readings.
Right, let's see what the voltmeter reading is. Now the voltmeter reading is 2.76 and the ammeter reading is 0.411 amperes. And we open the switch.
Now we have three sets of readings of voltage and current for combination A. From these readings, we can calculate the resistance of combination A and will obtain three answers. These three answers are used to give an average value of combination A's resistance.
The average value of combination A should also be recorded in the table of results.
It's time to move on to measure the resistance of combination B. We're going to take the same type of measurements, that is voltage and current, 3 times. And then you can calculate the resistance for each set and average resistance of combination B.
Right, we close the switch and check the readings on the meters. So the voltmeter reading is 2.85 and the ammeter reading is 0.190. And we open the switch. We wait a moment to let the combination of the resistors cool down to room temperature again. This may sound like we are being extra careful. The temperature difference is possibly only a couple of degrees, but a change in temperature will affect the resistance, so it's worth the while to wait.
Right, that's long enough. Let's repeat the readings. Close the switch.
Now let's see what the voltmeter reads. The voltmeter reads 2.84 and the ammeter reads 0.190. And we open the switch.
Let's take the last reading now. Close the switch.
The voltmeter reads 2.84 volts and the ammeter reads 0.191 amperes. And we open the switch.
Now we have 3 sets of readings of voltage and current for combination B. From these readings, we can calculate the resistance of combination B and its average value.
We can pack up the apparatus now that we have taken all the measurements. Your worksheet has a few more questions for you to answer individually, as well as the table of results for you to set out by yourselves. Remember to hand in your work. This investigation forms part of your portfolio of work for the year and counts towards your continuous assessment mark. Take care to complete all the answers and to do your best.